For all of human history, the stars have been beautiful, distant, and unreachable. We are tethered to our home world, adrift in a cosmic ocean. Our fastest spacecraft would take 75,000 years to reach the nearest star. The speed of light is the universe's ultimate speed limit. For decades, Star Trek's warp drive was a dream of breaking free, a symbol of science fiction. Until now. In December 2025, a landmark study revealed a discovery that has changed the conversation on faster-than-light travel. New research explores a design that works within Einstein's general relativity, but in a much more achievable way. Today, we're breaking down how the geometry of warp drive has started to look plausible, and how science fiction is becoming scientific theory. Stay with us as we explore how humanity might finally become an interstellar species. First, let's understand the problem: distance. The nearest star system, Alpha Centauri, is 4.3 light-years away. To get there, our fastest probe, Voyager 1, would need 75,000 years. That's not a trip, it's a geological age. The problem is Einstein's light-speed barrier. As an object with mass approaches light speed, its mass increases, requiring infinite energy to reach the limit. You can't break this cosmic speed limit, but there's a loophole. The universe itself expands faster than light, carrying distant galaxies with it. The law is that nothing can accelerate through space-time to that speed. So what if, instead of moving a ship through space, you could move space itself around the ship? This idea, moving space itself, is straight out of Star Trek. In 1994, inspired by the show, physicist Miguel Alcubierre developed the first mathematical model for a real warp drive that was consistent with Einstein's equations. The Alcubierre drive was brilliant. It proposed creating a warp bubble of spacetime around a ship. By shrinking space in front of the bubble and expanding it behind, the ship rides a wave of spacetime without actually moving through it. Since the ship itself isn't accelerating, it doesn't violate relativity and can theoretically travel at any speed. But there was a universe-sized catch. Alcubierre's math required exotic matter with negative energy density stuff that weighs less than nothing. For 3 decades, this negative energy problem seemed like an insurmountable hurdle. For years, scientists like Dr. Harold "Sonny" White worked to lower the energy requirements, but the need for negative energy remained. Then, in December 2025, the game changed. A study led by Dr. White and his team introduced a completely new geometry for a warp drive. The breakthrough: instead of one continuous warp bubble, the new model uses multiple, separate regions of spacetime distortion. The paper outlines a design using discrete structures the team calls warp nacelles, a direct nod to the Starship Enterprise. The implications of this new nacelle-based architecture are huge. It makes the drive more stable and creates a safer separation between the intense physics of the engine and the crew's cockpit. Crucially, while this model does not eliminate the need for negative energy, it changes how it's used. By localizing the energy into modular nacelles, the challenge is refined from a vague, universe-sized issue into a precise engineering problem. So is it time to build starships? Not quite. The greatest obstacle remains creating and harnessing negative energy on a large scale. This is the final barrier. Dr. White's own company is now tackling this head-on, giving research a much clearer target. What the 2025 study has done is shift the conversation. The question is no longer, is it possible within the laws of physics? The new research suggests the geometry works in theory. The question has become, can we engineer the parts? The problem has moved from fundamental physics to technological breakthroughs. What are your thoughts on this new research? Do you think we'll see warp travel in our lifetime? Let us know in the comments. And if you enjoyed this look into the future, be sure to like and subscribe for more. The journey to an operational warp drive will be long, perhaps taking generations. But for the first time, the blueprints look like they might actually work. The dream of Star Trek is no longer confined to our screens. It's a serious theoretical possibility. The idea of crossing interstellar space in weeks instead of millennia has moved from fiction to the world of scientific pursuit.